That was funny. Okay, quick recap stuff on probability. I'm going to cover some basic stuff first that I am not 100% sure that you are actually working on. Some I know you are, some maybe not, but you're probably going to get to. And then I know your mom said theoretical and experimental. So we're going to do all of those. This is my second time starting this because I was having technological difficulties where I wasn't getting it to read the iPad. So here we go. I am going to try again. So let's see if it works this time. Yes, it's working this time. Yay. Okay, here we go. Probability. I'm trying to get space, so I'm going to look like I'm getting farther and farther away because I'm just pushing the computer farther and farther away. That way I have space to put this so I don't drop everything on the floor. So the main thing to remember about probability well, now this doesn't want to work. What is up with this day, huh? Is this going to work now? Yes, there we go. Okay. Now I can finally write. So probability of an event is the number of ways it can happen divided by the total number of, I guess, ways or outcomes. Okay. Example here would be flipping a coin or rolling a dice. So if you have one die has 6 sides. So 6 sides. You have a 1, a 2, a 3, a 4, a 5, and a 6. Each of those are your different sides of the die. Now, if somebody asks you what's the probability of rolling, say, a 2, they want to know how many times, how many ways, or your chance of rolling this number right here. So what you would say is, this is only one time. It's only on there one time. So the probability of rolling a 2 is 1/6. Because the 2 is on the die only one time. There's 6 sides. So the number of ways you can roll a 2, you can only roll it one time because it's only on there once. The number of outcomes are 6 because there's 6 sides. So that's why you have the 1/6. Now, if it says something like, probability of rolling a 2 or a, I don't know, 5. There you go. This time you have 2 numbers. So you have 2 choices. So for this one, it would be 2/6, or you simplify it and you get 1/3. So you have a 1 in 3 chance of rolling either a 2 or a 5. The other big part to remember for probability is you can do fractions, you can do decimals, whatever. It's a percentage. The big part is that, here we go, I'm going to write it out. The probability of an event has to be between 0 and 1. It cannot be a negative, and it cannot be over 1, mainly because you can't have a negative chance of something happening. And 100, the number 1 equals 100%. You can't have higher than a 100% chance. So whatever your probability is, it has to be between 0 and 1. That's it. Now, another part, if you were using this first one we did, let's see, can I erase just that little part? I'll just rewrite the 5. There. If we were writing this in their fancy way, and I refer to it as their fancy way or their pretty way, this is the part that I don't know if you're covering yet, but it's coming. So I figured may as well knock it out before I move on to the experimental and the theoretical. The way they like to write this junk here is they would say, this is, we will say, event A. So your probability of something happening for event A would be, well, I guess I'll write that. Probability of event A. Oh, by the way, I don't know if I told you or if you know it, I'm dyslexic. So when I'm writing out words, it throws me, and you'll see that I have to pause a lot and I sound everything out. And yeah, sometimes I will totally flip-flop it. So sorry, it takes me forever to write this stuff out. Anyway, probability of event A would be written as P of A. That means probability of event A. So on this one, this would be probability of rolling one number would be written like that. And so you would then say that would be 1/6. So if they're trying to make it look fancy, that's all that is. The other part is if they give you more than one event. So you have a probability of event A and a probability of event B. This is when they then say which one is more likely to occur. Here, if it is probability of event A is greater than probability of event B, that just simply means that this one is more likely to happen. An example of this could be if event A is rolls anything other than a 6. And this could be rolls a 6. If you did that, then you would say probability of event A is going to be 5/6 because anything other than a 6 means the other 5 numbers. And then probability B would be just 1/6. So since 5/6 is greater than 1/6, that means this is more likely to happen. So I hope that makes sense. It looks a little odd, but I wanted to go ahead and show you these probability of, kind of like if you've done the functions yet. It's just, I don't know. It's the way math likes to write things to make it look a little confusing, but once you get it, it's not that bad. Yeah. Since your mom said you haven't been doing Venn diagrams, I'm not going to go into the more in-depth, but let's see. What's funny is I'm erasing this, not knowing if I actually need any of this or if I'm just going to stop using this. I have notes to what to make sure to cover. Okay. Okay, I have this, but I don't think I need to actually write this stuff out. So I'm going to stop this one. And the reason I don't think I have to write this stuff out, so yeah, I seriously just went through all that crap to make the iPad on there when I'm not even going to be using it for most of it. I'm sorry, it's been a heck of a few days. caffeinating. Okay, so, all right, real quick. And yes, I'm looking at my paper where I wrote my notes. I am fanatical about writing notes because I forget everything. So theoretical. If you're covering theoretical and experimental, theoretical is basically what you think it's supposed to happen. So example of this would be if you're flipping a coin, you have one of two chances because there's only two sides to a coin. That's why they like to use coins as an example. So the theoretical chance of, say, flipping heads. If you flip the coin, you have a 1 in 2 chance. So it would be, you have a 50% chance or a 1/2 chance to get ahead. So that would be theoretical. However, realistically, is that always going to happen? So if you flip it one time, yeah, you have 1 out of 2 chances. But if you're flipping the sucker like 20 times in a row, do you really think you're going to get heads exactly 10 times? Probably not, because life doesn't work that way. Life is a little bit crazier. And so experimental is like running a test. So science-wise, if you've learned about the scientific method and it says experiment, that's always a test. That's just what you do. That's just, you know, that's your actual tactile, which put your hands on, your test results kind of thing. So if the experimental flipping of the coin for heads is 1/2, and then I think I just said that wrong. Theoretical. I think I said it right. I don't know. Again, it's one of those days. So theoretical of flipping the coin for heads would be 1/2. Experimental would be what actually happens. So say you flip the coin 20 times in a row. And when you flipped it 20 times in a row, it landed on heads 8 times out of the 20. Your experimental probability would be 8/20 because you flipped it a total of 20 times. You got your desired outcome 8 times. So that would be 8/20. Now, most teachers are going to want you to simplify. So if you simplify 8/20, you're going to get 2/5. So 2/5. 2/5 is not the same thing as 1/2, clearly. And so that's showing there's a difference between your theoretical and your experimental. If you then decided to flip the coin a total of 100 times, if you are using your theoretical stuff, then that would end up giving you 50 times that you get heads. But since you did the experimental of flipping it 20 times and it only landed on it 8 times, you know that it's not going to be that easy. So that's where it gets kind of crazy. Now, I have Khan Academy has a really, really, really great site on this. So I was going to share the screen with you on that. And I think I have it here. Yep. And then walk you through a couple of those. So what I did is I sat here and I flipped through. This is the website. And I will make sure to send this link to your mom so you guys can play with it. These are videos that will walk you through everything. I'm not doing the videos. I'm just going to where it talks about stuff, because here it's talking about the dice, the different outcomes, and it has some more videos. Videos I know help a lot of people. However, I like to just do these. This way we can talk it through with the actual problem. So if you look here, Greg has an MP3 player called the Jumble. Interesting. The Jumble randomly selects a song for the user to listen to. Greg's Jumble has 6 classic songs, 7 rock songs, and 9 rap songs on it. And it wants to know what is the probability of it not being a rap song. So for this, the first thing you need to do is figure out what the total is. So you would do 6 plus 7 plus 9. So it's a total of 22 songs. And they just want to know which one is not a rap song. So that's going to be the 6 plus 7, or you could do 22 minus 9. But anyway, that's going to give you, there are 13 songs that are not rap songs, and then divide it by the total number of songs. So it should be 13 over 22. And by the way, they have a calculator here. I guess I could have done that. There you go. Now we get to the next question. Apparently the calculator does not go away. Ooh, I wonder if you can move the calculator. Oh, heck yeah, you can. Okay, we're just going to do that instead of using mine. So Omar ordered his sister a birthday card from a company that randomly selects a card from their inventory. The company has 21 cards in inventory. 14 of those are birthday cards. Now, what is the P, which is probability, that it is not a birthday card? Well, 14 of them are birthday cards, 21 total. So you say 21 minus 14. So there are 7 cards that are not birthday cards. So this should be 7 over 21. Yeah. We already know that the dice, there's 6 sides. So this one says it is a fair 6-sided die. Fair means it's not weighted, so you can't cheat. What is P, the probability that you will roll not a 3? Well, I already showed you this a little while ago. 3 is only on one side, so that means you have 5 that are good. So 5 out of 6 of not 3. Now marbles, they so love to use marbles with the probability. You randomly draw a marble from a bag of marbles that contain, I go ahead and start adding right here, 3 blue plus 4 green plus 5 red. So we have 12 marbles total. What is the probability that you draw a blue marble? Well, we have 3 blue marbles, so 3 over 12. Now again, your teacher's probably going to want you to simplify. Give it to you. Okay. You roll a fair 6-sided die. What is P, the probability that the roll is greater than 4? This is the trick right here, greater than 4. There's only 2 numbers on there that are higher than 4. That's 5 and 6. So that will be a 2 over 6. That one is one of those where you have to be careful of wording because it might be equal to or greater. So be careful of the words. Then you have these fun little ones. You see the spinner shown below once, or you spin it once. I guess you can see it as many times as you look. Each sector shown has an equal area. What is the probability of a not shaded sector? So you have to count. So I start where the arrow is and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, my bottom number is going to be a 12. And then I scroll back over and now not shaded. 1, 2, 3, 4, 5, 6. So not shaded is 6. So I should have 6 over 12. And no, you didn't have to type it in like that, but sometimes they're tricky and it's not perfectly even. There you go. And then final, Jake is going to call one person from his contacts at random. He has 30 contacts. 16 of those contacts are people he met at school. What is the probability to call a person from school? Well, 16 of them he met at school. So they've already given us all of our numbers right there. We don't have to calculate anything. There you go. And that is simple probability. Yay. Okay, now to get to, where was it? Theoretical. I played through this one a little bit. It drove me a tiny bit crazy, but I got it. I don't know if you have done the random samples or not, and so I don't know whether or not to cover this stuff. I truly don't know. Let's see. I think I'm going to go back. I think I'm going to go back to the iPad so I can write out a couple of experimental theoreticals for you. Whoops. To kind of help you see. But first I have to turn everything on and then we're going to be done. And again, if you see something on there that you actually needed more of, just tell me and we'll get it done because I can always do more later. There we go. Okay. Okay, so I am going to use dice, or I should say a die for this one. I am going to say we have our theoretical probability. Okay, so we're going to say, what is the theoretical probability that you will roll a 1 on a fair die? So roll a 1 on a fair 6-sided die. And I don't know if you played D&D, but your mom will totally understand why I'm specifying it's a 6-sided die, because if I don't, it totally changes everything. So theoretical probability of this would be P of 1 equals 1/6. Probability is seriously just 1/6 because there's 6 sides to the die and you only have 1 shot of rolling a 1. Now, the experimental probability is if you actually did this. But sometimes it's not going to be quite exact. So you're going to try to figure out what are your chances of something happening. So if you said, what are your chances of rolling a 1 if you roll the die 10 times? Well, all you have to do here is it is P, and I will just say event A equals, I'm sorry, not equals, times, and then the number of rules. So for this one, that just means the P of A, that's what this is. So that's going to be 1/6. And then if I say 10 rolls, just do it times 10. So 1/6 times 10, that's going to be the same thing as this. So that's going to give you 10/6, right? I'm sorry, I was thinking I was going to roll it more than 10 rolls, but I just did 10 rolls, so now I have to redo this. 10/6. Oh yeah, that's not a big enough number. That's weird because you can't roll it like that. That's not, yeah. We are going to change it like I was thinking originally, and we are going to do, there we go. We're going to do 60 rolls because that makes it so much easier. There we go. So we're going to say this, 60 rolls. So probability of rolling a 1 if we roll the die 60 times. So that is the same thing as 60/1 times 1/6. And so that will give you 60/6, which will give you 10. So you are probably going to roll a 1 10 times. So that is the probability of it. That is not the actual, because as you know, it doesn't always work that way. And if you ever played these types of games with people, for some reason, you will run into people who know how to, I don't know, My son is phenomenal with die. Although he also is very, very loud with them. He likes to put them in a cup and slam. But anyway, theoretical probability is when you're looking at it just one time, what it looks like it should be. The top number is the desired outcome, and the bottom number is the total possible outcomes. Experimental is the test. It's what you've actually accomplished, and that's why it doesn't always match. So a lot of those, like I said, are going to be things like you flipped the coin 20 times and it landed on heads 8 times. And so that would be 8 over 20 because that's how many times you did it. I don't know if you've gotten to the doing multiples in a row, like what are the probabilities of rolling or of flipping a coin and getting heads 3 times in a row. If you do that, it's just 1/2 times 1/2 times 1/2. And that's how you would get that probability. If you're doing or, an or statement, like what are the chances of drawing a blue marble or a red marble, you add those. So like if you had 3 over 10 for the blue marble and 2 over 10 for the red marble, then you would do 3 over 10 plus 2 over 10, and that would give you 5 over 10. So your chances of drawing a red or a blue marble would actually be 1 and 2 because 5 over 10 simplifies to 1 over 2. I know there's more, but not having actual worksheets and knowing specifically and not trying to give you too much makes it a little more difficult. So check this out, see if it helps. I'm also sending the link for the Khan Academy. I highly recommend going through it, checking out the videos, practicing. The little practice thing that I did, you can keep doing that. It'll give you new questions each and every time, and that should help. Yeah, I think that's it. Tomorrow's travel day, but if I get a message from you or your mom tonight or tomorrow, Monday, I can make some more stuff Monday to help finish it up. If you have homework or any of those things, send it to me so I can look at it. Even if you have already answered it and you send me what you answered, I can look over it and say, yeah, that's good, or no, it's not, or point out where there's a mistake. I just need a little more detail on exactly what you're covering because probability goes crazy, but it's really not that difficult once you get it. But it seriously 100% boils down to the number of desired on the top and the number of possible on the bottom. That's really all it is. So hope it helps and let me know.